Perfect. Okay. Then just let me share my screen real quick. And please just let me know when you can see something, just to confirm that I'm not talking to myself.
Oh, we can see your we can see your screen.
Excellent. All right. So today's topic is responsible AI on Azure. My name is Gabriel Werner. I'm a cloud solution architect for data and AI based in Munich, Germany. And before we go and talk about responsible AI on Azure, I would like to start with a couple of economic benefits, because as at TUM, we know it's a university that is meant to create things for companies, right? So they actually gave themselves the slogan Unternehmerische Universität. So this is why I think this is a very important aspect here. So why should you use cloud in the first place? And the reason is because when we compare cloud to other opportunities that we have, then we see, on the other hand, we see an on-premises infrastructure. And in an on-premises infrastructure, it actually doesn't matter how much you use it, but you always need to be able to support 100% of your capacity. And in the cloud, however, you can scale it up and down on demand. So if you have very high peaks, so as you can see here, traffic peaks, then you can just use more CPU, GPU, RAM. And if you don't need as much CPU, if the traffic is lower, you can scale it down. And you can then also share the same infrastructure with others, and thereby it results in a lower price. So essentially, you're shifting the CapEx to the OpEx, so the operational costs. So that's a little bit of economical background information then. Now let's take a closer look at AI on Azure. When we talk about AI on Azure, we will realize that there are essentially three different possibilities to use or to make use of Azure for your AI applications. On the first hand side here, this first pillar, you will use Azure only as an infrastructure provider. So that means it's essentially a virtual machine that you can spin up, and then Microsoft takes care of the virtualization, the servers, the storage, and the networking for you, and you have full control of your hardware. So you have a maximum amount of control here. However, the downside is that you actually need to think about operating systems, middleware, and runtime. So the second possibility that you have in Azure, if you're planning to do artificial intelligence, is to use a platform service. Actually, we have two different platform services that are able to that are meant to be used by data scientists, Azure Databricks and Azure Machine Learning. And today we will talk mostly about Azure Machine Learning, and Julia will also give you a very good overview on Azure Machine Learning, especially on the notebooks later, so stay tuned to that. And in this platform as a service offering, Microsoft also takes care of the operating system, the middleware, and the runtime. So that means you as a data scientist can upload your data to this platform and be productive from day one. You don't need to care about package dependencies, scaling up and down, because this is all done by Microsoft for you. And then I would also like to emphasize a third tier that we have, because I know that in a hackathon, time is crucial and is limited. And we have established, or we have during our Microsoft's endeavor in the AI space, we have encountered a multitude of use cases that have already been solved. And for example, face detection, optical character recognition, image detection, anomaly detection. So these kinds of use cases that have already been solved a number of times on the market. So for this, we provide you software as a service. So and actually, here we talk about the so-called Azure Cognitive Services. So the Azure Cognitive Services is a library of services that you can use out of the box, and those are pre-trained models for various use cases. And we can cover those in more detail later if we have the time. But yeah, and this is maybe just an overview on Azure Machine Learning. Again, so here we have it's as a productive service. Here we have Databricks, we have the machine learning VMs, and you can also use Azure Machine Learning and scale it up and down on demand. You can use, you choose the amount of CPU that you want to have, the amount of GPU, and also these field programmable gate arrays, so very dedicated hardware to your needs. Azure Machine Learning is an open platform, so that means we are not locking you in our infrastructure, but you can continue to use the popular frameworks that any data scientists like to use, such as PyTorch, TensorFlow, Scikit-learn, Onyx, etc. We also have, however, our own SDK, Azure Machine Learning SDK. We will also cover that later. And you can continue to use the IDE of your choice, so whether this is a Jupyter Notebook or a Visual Studio Code, or if it's the command line, so you're free to use any IDE that you like. And obviously, you can also integrate the cognitive services. So if you remember the right tier of the 3 columns or the 4 columns that I showed you earlier, you can also use the cognitive services on top of this platform offering. So it's you're not restricted to one of these offerings. All right, so that being said, that was a little bit of an overview. Now I would like to dive a little bit deeper in the topic of responsible AI. And now you might ask yourself, why should I actually care? Why is this an important topic? And I would like to tell you a story. So it was a couple of years ago, and AWS, so at Amazon, they have actually trained a machine learning model that predicted whether an applicant based on the CV should be hired for a job or not. So they trained a machine learning model that answered this question. So a predictor, essentially, or a classification algorithm. And what they found out after the model was in production, they found out that if you use the same CV, so the same resume, and you change only the gender of the applicant, then the resulting score actually changes. So in fact, for women, the same resume, but the score becomes lower. And here we can see that the task of a machine learning algorithm should not only be to best approximate the target metrics, because if the training data is already flawed, is already biased, then you will replicate this bias into your model. And if we talk about automating our lives, we must make sure that the model does not discriminate or does not do any mistakes, or even if our training data is biased, that we detect these biases and we don't reproduce these biases in the models. So it helps us to avoid discrimination. But it also helps us if we think about high-risk environments, such, for example, if we create a stock price predictor, and then potentially there are millions of dollars of losses if we are unable to interpret the results of the outcome of this machine learning model. And therefore, Microsoft has established AI principles. So whenever we create a machine learning model or something related to artificial intelligence, we want to be fair, we want to be reliable, we want to keep your training data for yourself, so topic of privacy. We want to include everyone. We will be accountable for our technologies and transparency. So I think we will look at this in just a tick in more detail. So let's take a closer look at Microsoft's approach in Azure in the topic of responsible AI. Just let me open my portal here for you. Oops. One second. There we go. So when we talk about responsible AI, one very important aspect is to actually be able to interpret the results of your machine learning model. Why is that important? Because if we think about glass box models, such as linear models, decision trees, rule lists, explainable boosting machines, it is easy to understand for us humans why the model actually behaved the way it behaved. For black box models, it's not so easy because if we think about deep learning, you have so many hidden layers that at some point it becomes too difficult to actually find out or to explain how the model achieved its results. And therefore, we have this interpret ML package, so it is open source. So even if you decide to not, so you can access it on GitHub, so github.com/interpretml. So even if you choose to not use Azure, you can still use the interpret ML package. This is because Microsoft thinks that everyone should actually use the interpretation engine. So we are not restricting it to Azure users only. So yeah, we have black box explainers in the package. We have a glass box model explainers as well. We also have diverse counterfactual explanations. For example, why is this important? Because if I'll just give you a random use case. So for example, if you create an algorithm that predicts whether a person gets a loan or a credit or not, then possibly a person applies for a loan and the person gets rejected, but then you also might want to answer, or you also might want to have additional explanations on that. So for example, what do I need to change in order to get the loan next time? So this is why we have these diverse counterfactual explanations. So it uses the same model in different variations, and then you can have a little bit of clarity on these models. How do you actually use it? And then I'll stop talking and I'll show you how it looks in the portal. So in practice, it's very easy. Julia will also talk about AutoML later, but it is very easy. You just set if you choose to use Azure Machine Learning as your IDE as a data scientist, then you simply set the model explainability flag to true, and then you can view explanations in the Azure Machine Learning portal. So let me show you how this works. All right. So I would like to use this example for you, right? So here we have a data set of different customers. Actually, they are banking customers. So we want to predict essentially whether a person decides to buy a financial product or not. So here we have a 57-year-old technician. He is married. He was at high school. There was also a publicity campaign for this person, and the campaign was 370 days long. So this company heavily invested in this customer. So 371 days of a publicity campaign is a significant effort, only to find out that here in the end, depicted with the Y column, this 57-year-old technician decided to not buy the product. So this is the target column here. This is the Y. So this person decided to not buy the product. And I have created and actually Julia will also guide you through the process of automated ML later on. So we will keep this superficial because we will dive in deeper later. But we have a set of algorithms that I have created, and as we can see here, this voting ensemble algorithm predicts the outcome here depicted with the Y column at an accuracy of 94%. So the area under the curve is 94%. So this is pretty good. And now what we can do with our explainability package is we can click here, and then it loads. So just give me a second, and let's switch to this dashboard experience. And now we can create a number of plots in order to try to understand the behavior of our model a little bit better. So let's fine tune the X value here. Let's maybe select the age, and the Y value here, we have the duration. So keep in mind again, the duration here means that is in how long this person was exposed to this campaign. So as we can see here now, we have we can plot these two values against each other, and we can then see that here, I don't know, this person here aged at 31 years old actually had a significant duration here, 2,000 days of a publicity campaign. Yeah, actually, now that you ask me, I'm not even sure if that value makes a lot of sense, but you can see that generally people get exposed to these campaigns much less. So yeah, so you can create these kind of plots. What you can also see here is you can calculate global feature importance. So as what we can see here is essentially the correlation between a feature and the outcome here, y. And what we can see here is that the duration of the campaign seems to correlate quite well with the target metric y. So one result into looking at this feature here is, or one argument or one conclusion that we can derive from this dashboard is that we should probably invest more money in extending the length of our publicity campaign, because the longer the campaign, the higher there is a probability to have a successful outcome. And what we can also see here is, for example, that the age does not correlate at all with the outcome, whether the person will buy this product or not. And this means now for me as a data scientist, I can conclude that I do not have a specific target group for this product that I'm trying to sell here. So yeah, these are also a kind of some conclusions that I can derive from that. And now back to the story. If you remember the resume story that I told you earlier, if, for instance, we found out, if we created a machine learning model that predicts whether a person gets hired or not, and then if we find out that gender seems to correlate well with the outcome of the machine learning model, then I can I have this is proof for bias in my data set, right? So with these kinds of thoughts or with these kinds of plots here, I can avoid discrimination in the best case scenario. Right. So this is AutoML. We will look at the AutoML in just a second, but you can also run AutoML from within the Jupyter notebooks. I think maybe this is the right point looking into Julia's direction to do the handover and maybe look a little bit deeper into Azure Machine Learning.
Yeah, that's fine. I'm ready. Okay. Thank you so much.
Sure. And by the way, we will there for your questions and answers later on. So if you have any, then we will make sure to answer them in the end.
Perfect. Thank you very much, Gabriel, for that talk. And now we move forward with the second workshop of the day, and that is a hands-on Azure workshop by Julia Kabalar. And she is a proud member of TUM.ai. She is a specialist working student at Microsoft in the field of AI, and she has a background of at Robotics, Cognition, and Intelligence. She's doing her master's studies at TUM, and we'll talk about doing machine learning in Azure. Hello, Julia.
Hi, Peter. Thank you so much for introducing me tonight. I'm indeed proud of being here tonight, but in particular because I'm a TUM.ai member. And I'm really happy to be here presenting machine learning with Azure tonight.
I'm glad to hear that. The stage is all yours.
Thank you. So I think by now you should see my screen. Maybe
yes, we can see your screen.
All right. So Gabriel already gave you a very nice introduction of one of the topics that is really, really important for me, the responsible AI topics. Sure, like we can all define the responsible AI principles, but it's just really nice to see how, as a data scientist, you can actually implement them and see real-world scenarios where you can really identify potential harm or priors against groups. And it's a really nice tools that I encourage everyone to check out. So today with me, we will be looking at Azure machine learning, and particular doing machine learning with Azure machine learning. So what is Azure machine learning? Azure machine learning can basically help you to simplify your models with automated machine learning, but not only that, you can also build your own models that you can easily scale using the cloud. So, but how can you actually get started? So you can always get your free subscription to try out on working in Azure. So I encourage you to check out these links and get started in the cloud. So automated machine learning, I will just continue on Gabriel's example, actually. So let me switch back to the data set. So we have discussed that we have different features and a different knowledge about our potential customers and how the marketing campaign go. And what we actually want to predict is our yes/no value, which basically says whether the marketing but whether actually the customer has bought the product or not. So when we look into the Azure Machine Learning Studio, you can check out different blocks. So we have here the notebooks. We'll have a look later on how to use them. We have here the automated ML block, where you can automatically train and tune your models. And we have the designer interface, which can also help you to create and deploy your models. So let's get back to our example. So here we are basically in the automated ML interface. And what we can do is we can basically explore the model and hyperparameter space using automated ML. And we want to do this in order to figure out what is the best model, as we are not too deep into the topic. We haven't had enough experience to know which algorithm works best, or sometimes you just don't know. So you can get started by uploading your data. And this is like the first step you take in automated machine learning. You upload the data, you tell the framework which type of data it is, you continue, and now you're able to configure your run. So we will just give the experiment a name, and we will be later able to access everything that we configured here in our experiment. So you will have the version control, and you will be able to see everything afterwards. So now comes the important part. So we have to select our target that we actually want the model to predict. So here in this case, we have selected the Y column, which is our class, let's say. So we want to know yes or no, a simple decision. So we can now here either create a new compute. In my case, I just use my cluster that I created beforehand. And then we select the task type. So here we can choose between 3 types of different machine learning, let's say, domains. So we have either the classification one, a regression, or time series forecasting. And as you can see, this is really nice if you have a like a form of a data set where you have, for example, a CSV file and so on. Like, this is really nice. You can also do it with images. So then, after you have chosen the type, in our case, it will be, as we discussed, yes or no. So then we can check out additional configuration settings. So we can choose this metric that Gabriel mentioned. So maybe we don't want area under curve, but we want to see, like, okay, what will be the accuracy that we can achieve? And do we want to automatically show the explainability of the best model like you've seen beforehand? We can define the exit criterion just to make sure that we are not wasting too much money in case something goes wrong. Here is the validation type. You can also switch it and choose some different validation type, like k-fold or other types of validation, and you can pick the concurrency. So then you can also look a bit deeper into the features that are already imported from the dataset. So for example, maybe you want to make sure that some features are not included, like some information about, for example, the age. You don't want to have it included just to not generate any kind of bias, or like just that you are sure that the outcome of the model is not influenced by this feature. So after you have done this, you can basically let the model train, and we can go back to our result that we have already created before. So we have a look into this model, and we can just obtain from our run like really interesting information. So for example, here our automated ML framework has already detected that our classes were not balanced. So we didn't have enough data from different types of classes that we want to predict. So it's like hard for the machine learning model to actually make sure that the result will be right. So what you have here is now the model space. So what we told you before is that it will explore a lot of algorithms, and what it will actually do is it might stop at some certain point, because it will realize that it cannot continue with one model because it might just not perform well. So there will be some pre-pruning, and you can also have, which in our case is, or I think was the best working model, is an ensemble model. So you have this ensemble model, which might be, like a decision tree, which says, okay, for this kind of data, or for this particular sequence of data, this algorithm works well, but for the other one, we choose the other one. So we have like an ensemble algorithm which worked best. And we see here all the interesting parameters that we actually tested and also explored during our modeling phase. So getting back to the explanation view is that we've already seen here you can directly access the features and the explainability tool. And yeah, I think that was all I wanted to show you, right? Yeah. So I will get back to my presentation. Yeah. So just a quick recap, like we can explore different types of algorithms, different types of parameters, and we can basically have a look which works best for our case, for our scenario, for our data set, and then our automated machine learning can basically help us to accelerate the model development. So this is a part where we say, okay, the framework actually takes a lot of tasks, and we basically get a hand on how to find our algorithms, how to find our hyperparameters. But also Azure supports open source frameworks. So for example, if you want to use PyTorch or the framework, deep learning framework of your choice, you're really, really free to use them. Also, Onyx is a really, really nice tool which can do the job for you to train your model on one framework, but then transfer it to another one for inference. So you're not getting locked into one framework. So when we are focusing on building machine learning models and how Azure Machine Learning Model can actually help you with this process, we are starting with 3 high-level building blocks, which is preparing the data, building and training, and then deploying. And these are also the essential parts of the Azure Machine Learning SDK, which is a tool that actually makes data scientists more productive. And we will give you later on some short examples on how you can actually use them. And the best part about it is that there are a lot of free tutorials available for you that you can try out yourself and see how you can work with it. And you can also interact with it, for example, through Jupyter Notebook or your other favorite IDE that you would like to use. So yeah, so just some small information about it. You can access it from anywhere. You can deploy it on in your local environment or in the cloud, and allows you to integrate with other Azure services. So you can get started quickly. You just need a subscription. So what I did here is like I just copy pasted some code snippets because this could actually help you to get started with the Azure Machine Learning SDK, but obviously it's a bit easier if we just have a look into the service itself. So from here, I would like to show you one example that I myself trained using the Azure Machine Learning SDK.
Sorry to interrupt you, Julia. Would you mind zooming in on the Azure platform because the letters are too small and not readable? Like somehow zooming in. Perfect. Perfect.
All right.
Thank you very much.
No problem. So let's have a look. So we have here one famous data set, which is the MNIST data set, if I'm correct. Yeah. So probably all of you have encountered it during your machine learning classes. So I just have to find it. Yeah, here. So what we are trying to do is to interpret handwritten digits, and we want to train this on a cluster. So we can follow all of these steps and making it available for you in this platform. So what you can later on do is you can access it through your experiments. You can check out which kind of hyperparameters you use, which configuration you used, how long it needed to train. You can also, at the end, deploy it and connect it with other Azure services. And you can have a look onto the deployment. So later on, we see the results, and we can also see the false results. This is just to show you an example, like how you can use it. And where I have this from is from the tutorials that are provided within here in the sample notebooks. So if you're interested and you're trying out the Azure platform, just have a look into these examples that we have here on how to use Azure Machine Learning, and you can get started with different types of tasks. So for example, you can get started with reinforcement learning. You can also get started with responsible AI, or you can just try out some of the tutorials, which are basically guiding you through some of the standard tasks like image classification or creating machine learning pipelines in an advanced way, and so on. All right, so I think we we can go back to the presentation. So how do you actually manage the compute? So in our example, except for the previous example, now I have trained locally. So you can train on your Azure virtual machines or VMs that are computed, that can run on demand in Azure without needing to buy any hardware. But if you want to train bigger, you can use managed computes in Azure Machine Learning. And they will actually help you to spin up like your clusters of compute that you want to use. You can schedule your jobs, distribute data, and auto scale the virtual machines so that you're not just limited to one. So for example, for this Makeathon, what could you do? So you could, for example, create and manage a VM in Azure Machine Learning, and you can make use of the services that we have, like the cognitive services, computer vision services. You can use the SDK. You can use just the GPUs. Like you could make sure that you're leveraging the platform. So how would you get started? Like, you can basically create and explore your Azure Machine Learning workspace by going to the portal, just starting the Azure Machine Learning resource, like creating one, and then you can get into the studio and have a look at the available tools. And then what you should definitely do is to determine the size of your VM. So you should make sure that you have the right requirements, but you can also try out the automated way on how to scale your required resources. And then you can also, for example, use the like you can directly connect from Visual Studio Code, which is the best IDE ever. You can directly connect through the Visual Studio Code with your Azure machine, and you can start from there. What you can also do is you can just create and manage a VM in Azure without going through Azure Machine Learning. But of course, you will not have any of the benefits like the environment setup and like logging and tracking of your runs and so on. So we really recommend you to use the Visual Studio, the Machine Learning Studio. If this was too fast, which probably was because I'm sometimes speaking very fast, then just check out the tools, the docs that we have prepared on that. Just as a recap, so we have spoken about our 3 building blocks, which is preparing the data, building and training, and then deploying the model and then testing it. We have also talked about that we can manage our computes by leveraging the automated system or bringing our own compute. What you can also do is to use your own favorite open source tools. And now I will just jump into one more thing that I wanted to show you. So since I'm part of the TUM.ai organization, I already got one of the notebooks that we have prepared for you for this Makeathon. So if you're interested, you can just have a look and see what we have prepared for you. So it was very easy. So you can just clone the resources that we basically provide you for this hackathon, which will be notebooks that will be in the field of computer vision, NLP, and regression tasks. And we will have them prepared with links and resources to pre-trained models. And you can just import them on your local machine. You can use, for example, Azure, and then create your environment there. And you can actually use, for example, the SDK to store your environments in here. You can also use one of the predefined environments that are available in Azure Machine Learning Studio. and then you can execute the notebooks that we have prepared for you in here, and you can train on the Azure GPUs. You can, for example, like I have mine running. I just click myself through this notebook, and one of the examples that we have prepared for you is actually a semantic segmentation task. So we have this data set here, which is downloaded from randomly, actually from Google, for human skin detection research. So these images are captured with a range of different cameras, so you have a lot of variance in the pictures of the data set, and you can have a look on the folder structure, and we are just importing it, and we can visualize some of the data. Oh no, we can't. Okay, but I have the end result, which is after the training on this data set. Is basically we give you, for example, a ground truth image. We have the image, and here we can see the prediction of our model that we prepared for you is already quite fine. So you can really clearly see a difference between the skin and other parts of the face. Yeah. All right. Yeah, some more note on this. So like you can have, for example, environments that you have registered. You can, for example, create them by clicking custom environment, and then you can, for example, upload, I think, a contour information. You can upload requirements txt. You can upload other types of YAML and whatever files. So you can predefine your environment that you need from an open source framework, as you're free to use different types of frameworks in the Makeathon. And then you can register them and have a good overview and switch between them just from the designer. Yeah, something else, I think. Yeah. One more note on the models registry. So what you can also have here is that you have an information about the versioning, for example, of your model. Is sometimes hard to get an overview, and this is a really, really nice feature that you can make sure that you're not mixing up the hyperparameters that you used in one model or one training run, but you're basically aware of what you have used and how your model looked like. So, okay, and then I also, yeah. So, and this is like the part where you can use your own favorite open source tools, but you can also accelerate the time and to build models by exploring algorithms and hyperparameter spaces for you, which I showed you in the automated machine learning. And I really recommend you to check it out because it's a really great way if you want to save some time and have a nice, clear defined data set, and it's a really good thing to do. Yeah, some more notes on DevOps. So Azure Machine Learning also gives you the possibility to do, like these are more the traditional ways of continuous development. The same actually is valid for machine learning. You should be able to produce repeatable experiments and manage your model life cycle, which can really help you in developing your machine learning models. Just jump over this. So as a recap, so we have seen this picture at the beginning of Gabriel's presentation. So what Azure machine learning in Azure can really help you is to be able to address many different levels of expertise. So whether you want to start with pre-trained models to reduce your time to market, or you want to really use your favorite data science tools like PyTorch, TensorFlow, and so on. You can do all of this and use your favorite popular frameworks that you want to use and deploy it on really powerful architecture underneath. So how can you get started? As I mentioned, there are some free subscriptions for students available, and you can really start for free. But we really encourage you, and since it's quite evolving and there's a lot to learn about all these platforms and all these services that Microsoft provides, we really encourage you to join our skilling program. So we have currently opened the new skilling phase in October and November. So here you can have a look at the different courses which are available in German and in English, and you can start now. So you can start to obtain knowledge for probably, maybe it will help you for your next job. But the good thing is you can do it flexibly and 100% online, so you can learn whenever and wherever you are, and you can easily combine that with your studies. So we can recommend it to you because there's a lot of free resource for you available, like the materials and practice tests plus hands-on lab. But we also have a different announcement, which is that you will, let's say, there's a special offer for the TUM.ai Makeathon participants. So you will get free Azure examination vouchers. So there will be in our Slack communication, there will be a channel created, and please then send us an info, send us a smiley, a hands up, something that you are interested in receiving one of these Azure examination vouchers, so we can ensure that we make them accessible for you and that you don't miss out on this training opportunity. Check out the courses and have a look if you want to join them. And if you have some further question, I invite you for the socializing event tomorrow, which will be a more relaxed event where you can socialize with other participants, but also with sponsors and AI experts and the speakers of this week. So I really encourage you to join it. And if you have further questions, like you can ping me directly on Slack, but you can also get in touch with us, not only now in the Q&A, but also if you have some questions later on, you can just ping me a message and ping me on Slack. And yeah, so that was it from Azure ML.
Perfect. Thank you very much, Juliet. Thank you, Gabriel. And right now we will jump in the Q&A session. So to all participants, you can ask all of your questions in the channel number 1, so workshop and talks. I will read your questions, so feel free to write them down in the channel in Slack. And while we wait for your questions, I have received some already. So the first question would be for Gabriel. So when our main mission at TUM.ai is to make artificial intelligence accessible to all majors, not just for the technical sciences. So I would like for you to explain as to which questions does one has to ask themselves when choosing one of the 4 columns that you showed in your presentation. So infrastructure as a service, platforms and software as a service, and like what does one have to ask themselves before going forward further?
That is a wonderful question. Thank you so much. And it is indeed a very important one. And maybe I can answer the question with a mission statement that Microsoft has set to itself. So we have one of our big missions is democratizing AI. So what does that mean? That means that we see on the market that there is a huge number of possible use cases that you can achieve. However, there is only a small fraction of people that are actually capable to, that have the technical know-how to use or to train models. So what we are trying to do with our technology offering is to both be the company for developers, because Microsoft is a company for developers and always will be. So we have this stack. If you want to run, if you are deep into data science, if you want to train your deep neural networks and you have a very specific use case, then we encourage you to then you might want or you might even need the control of your hardware. So then in this case scenario, go and use the data science virtual machines or use Azure machine learning. Maybe this is in all other use cases, and I'm going to actually show you one slide with which use cases I actually mean. So let me share my screen real quick. For all other use cases, there already are, we have already solved them for you. So just focus on things that are new, right? And here is, for example, okay, we have talked a lot about these two tiers here, right? Actually, we have talked a lot about this one, but this one is just a virtual machine, so there is not so much to talk about because it's just a virtual machine. So we have talked a lot about Azure machine learning. So let's talk a little bit more about our SaaS offerings, cognitive services. So the cognitive services are actually a library of services. And I will actually put this on full screen so that you can read it. So just let me solve that. There you go. So the cognitive services can be separated in 5 different columns. Vision, and vision is everything related to object, scene, activity, detection, face recognition, celebrity, landmark, emotion recognition, text and handwriting recognition, OCR. We have customizable image recognition. Actually, maybe we should even look at this if we have. I think that we have a little bit of time left, so maybe it might make sense to look into customizable image recognition a little bit deeper, because it's just an amazing tool and it really facilitates or it reduces time to market significantly. So that is vision. We have a number of speech APIs, speech to text, text to speech, custom voice. Actually, custom voice is an amazing tool because it is so good that you cannot distinguish an artificial voice from a real voice. So it's fascinating to see the performance of custom voice. Yeah, check it out in the Azure portal. Language. So here we have contextual language understanding, NLP and engines. We have keyword extraction. We have sentiment analysis. We have translation services. In this 4th pillar, we have decision, so everything around anomaly detection and also metrics advisor that helps you on top of the anomaly detection to do root cause analysis. And then we have also Azure Search here, for example, our own Elasticsearch implementation, that enriches documents and makes actually a set of documents. It creates from a set of documents a searchable index. So to answer your sorry, that was a very long answer, I know, but to answer the question in one sentence, if you have any use case that you find here, then please focus on something that is new and don't waste your time to recreate what's already there in the market, because that's not, I mean, your time would be too precious for that, right? If this is interesting, if, for example, custom vision is interesting, then I have also a very short demo, but I'll just leave that in the room in case there are a lot of questions. I don't want to take all the time. So
I think we have received one question from the participants, and that is in one of the slides there was a mention of inclusiveness. How is it ensured?
How is it ensured? I mean, this is your task as a data scientist, right? So we provide you the tool set to. Okay. Sorry. Okay. Now I think I understood the question. Okay. For example, let's take the example of image recognition. In image recognition, what we have seen on the market so far is, or for face detection, for example, there is much more training data for white people than there is for black people. And this also results into a better accuracy for white people than for black people. So what we as Microsoft want to ensure is that no matter who you are and how diverse your background is, we provide the same quality of services to everyone. So this is for the cognitive services, right? For the right tier that I have mentioned. For the middle tier, we can only provide you the tool set, and you need to make sure that your as I think Julia has in a very short, I think in just 10 seconds, has shown that the dataset was not balanced, for example. With these kinds of guardrails, you can ensure that you would really provide the best performing model for anyone. So I think this is we can just provide you the tools, but you gotta do the heavy lifting in the end. But for the cognitive services, we try our best to include everyone. I hope that answers the question.
Yeah, thank you very much. I hope it cleared up some stuff. And then, the next question we have is, can Azure AI be integrated with TensorFlow?
The other way around, TensorFlow can be integrated in Azure Machine Learning. So yes.
Perfect.
And there is actually a lot of documentation on that. So if this is interesting for you, just pick the search engine of your choice, which probably is Bing, and type in TensorFlow on Azure Machine Learning.
Then I have one more question to you. Can you tell more about Azure Cognitive Services?
I think that was just the last slide that I have shown. Would you like to? We can dive into some of these capabilities in more detail.
I think we have 15 more minutes, so you can.
Yeah, I think there's time, right? Yeah.
Yeah. Okay, then maybe before we go there, then just maybe let's make sure to really cover all the questions in the chat. So
then
I also saw some on Slack. So can Azure AI be integrated with TensorFlow?
Yeah, we already.
Yes.
Yeah.
Yes.
Then the next questions I guess are for you, Julia. How would it be possible for a whole team of people to access the resources made from one person's account?
Oh yeah, this is. Sorry, that was for Julia. So I leave that with you, Julia.
Because you.
So that's the easy part about it. So you can just open basically the studio from any kind of browser device that you would like to use. So there's no problem about that, as you can just access the environment from the cloud. So yeah.
Yeah, maybe I can quickly show this because it's just 2 clicks. So whoever is new in Azure, so as Julia already said, the first thing you need is a subscription, right? So once you have a subscription, the next thing you gotta do is to create a resource group. And a resource group, you can think of resource groups, right? Like they are folders and they structure your different deployments that you have in Azure into groups. And then I have this testing resource group here, for example. And then we have this tier here, access control. And here you can actually create a role assignment. So for example, I can give access members here. Oh, they actually changed the UI. Nice. So I can select Julia. What was it? Kabalar. There we go. Yeah, and then I can select her, and then I would review and assign, and then she has access to my resource group, and then we can collaborate on the same workspace. So as easy as that.
Okay, then perhaps another question we got from the participants is, do we have to use automated ML for our challenge? That can be.
No, so there's no necessity to use automated ML, but you're free to use it. Definitely, it can help you on your tasks, but you're not obliged, and it's
That's perfect. So maybe another question from my side is, you have showed us in your tutorial that automated ML does supervised learning. Does it also cover unsupervised and semi-supervised?
Not from my knowledge. AutoML is restricted to classification, regression, and time series forecasting. So those are supervised learning use cases. For unsupervised learning, we do have tools that covers, for example, for, I don't know, clustering or things like that. We do have algorithms that you can deploy from the Azure Machine Learning SDK, Python SDK. So Azure supports it, but AutoML, from my knowledge, does not. I can be wrong on that, but yeah.
Okay, then we also received another question. Is it possible to shortly go deeper on the courses Julia talked in the end, duration, cost?
Yeah, I was about to reply to that one. I will make some information, some further information and links available on the Slack about the courses and availabilities and times, costs, and so on. Yeah, sure.
And perhaps one more question. We have seen that Azure covers many different frameworks. It can be used in many different scenarios. And we all know that artificial intelligence it's quite a complex domain. It occurs. There are so many new inventions that happen every day. And what does the future hold for Azure? What can we expect?
What does the future hold? We have a number of very interesting announcements. For example, we have a partnership with OpenAI for the GPT-3. So I think there was a little bit of a workload for TUM.ai with GPT-3, if I'm not mistaken. So stay tuned. There is a lot coming from Microsoft in this direction in NLP in general. What else? We have recently acquired. I think that was the most, the most expensive acquisition from Microsoft so far. We have acquired Nuance, so Nuance Communications, and probably we will also have a number of announcements coming next calendar year for that. So currently our NLP stack is LUIS, Language Understanding Intelligence Services. I assume that there will be some exciting things coming up. I mean, Azure is such a huge universe. If you want to stay tuned, I can highly encourage you to look at our blogs also, where we update our tools on a weekly basis. So check it out.
Perfect. Thank you very much. I think we have covered all questions from participants. Yeah. So we have 10 more minutes. If you would like to show us some other tutorial or anything that you have also prepared, you have more than enough time.
Mm-hmm. So I would love to show something more, because I think there were lots of questions around the cognitive services.
Yes.
So and that actually makes a lot of sense, right? Because in a hackathon, you have very limited time, and you want to make sure to show some kind of a demo in a very short amount of time. So I think the cognitive services actually fill this gap quite well, because all of these models are already pre-trained or are very easy to use. Some of them have a nice UI, and they can all be published at a public endpoint, and then you can use this public REST API endpoint to integrate the model into your applications. So this is how cognitive services work. In order to show you how easy, and here are some of the cognitive services capabilities. There's also a number of cognitive services demos. due to time constraints, we cannot cover all of them, but I'm just gonna, actually, I don't care which one, but I really like the custom vision demo, so I'm gonna show you the custom vision demo. So how does it work in a nutshell? Same story again. So in this resource group, testing, you can access the market, and you will write a custom vision. There you go. And then this marketplace, by the way, is also open for new products. So if in the end you decide to publish your own app on Microsoft Azure on the marketplace itself, this can also be a possibility. Just maybe, showing you all the possibilities. So you hit create, and then you need to guide. It goes through a wizard here. There is also this pricing tier. So no worries, there is a free pricing tier. My custom vision, and the free pricing tier is actually, okay, why is this not showing here? West Europe. Always try to select West Europe because this is the closest one. Okay, I've already used the free pricing tier. This is why it's not giving me a possibility. All right, but you gotta believe me, there is a free pricing tier. This one is not the free one. The free one is called F0. So make sure to hit the free one. And I think you have 5 transactions per second in the free pricing tier, so it is really generous. Okay, I'll quickly show you how it works, right? Because it's super easy. Okay, custom vision. We are trying to create a classification algorithm. Actually, we can either select classification or object detection, but I'm gonna select classification. And then my project, and then my description, and then I'll select my resource here, this one for instance, and then I will create let's create the project. And then it is really easy. So then this is my UI. I can now add images. And for example, I'm gonna add a couple of pictures from Picasso. So you can upload them. Picasso. And I'm labeling them with Picasso, so upload. All right, let's do the same again for Pollock. And it's super easy. All right, that takes the time. And let's do the same for Rembrandt as well. There we go. Upload files. And then, okay, you're done. And then you hit the train button. I'm not going to hit the train button, and then it will take around, I don't know, 10 minutes because I have already pre-trained it for you. So I'm just going to show you the result. My classifier. There we go. And it's just the same, just what I have just created. I have already pre-trained it for you. And then, you can hit the quick test button here on the top right. And then I'm gonna send an image that was not seen by the model yet. So for example, this picture here from Picasso, I upload it. And it predicts a Picasso at a 92% probability. So when I'm happy with the results, I can click on. I can publish these resources, and then I will receive a prediction API. And using this prediction API, so please don't make any screenshots with this. create your own resources. So with this resource, with this API, you can just integrate this into your, I don't know, Flask environment, and you're done. And you have successfully integrated a classifier into your application. So it's super easy, and it's a serverless service, so you don't need to take care about scaling up and down on demand because this is done for you by Azure. And so it's also super easy with. So for example, if you're more interested in OCR, for example, you can select check out the form recognizer.
Yeah, basically, you're not limited to only this. Like you can also detect, for example, like the objects in the images. Like you can do real object detection with bounding boxes and so on. So what we've seen now is only like a classification of an image, but you can also do more detailed analysis on the images and yeah.
Yeah. If this is interesting for you, then let us know, and we will. Yeah, we are happy to provide you with a deep dive for custom vision or any service that you like.
Sounds perfect. Thank you very much for that tutorial. And thank you, Gabriel and Julia, for this amazing workshop. I think we have covered all the questions. And right now we'll go into a 15-minute break, and then we will have a business talk. Thank you so much, guys, once again. And we will see each other. Bye.
Thank you as well,
Thank
and
you.
enjoy the hackathon. All the best. Good luck.
Thank you.
You. All right, as said, we will take a 15-minute break and we will have a business talk from Dr. Jackie Ma.
Welcome, Jackie. All right, I just changed you to presenter mode.
Ah,
So,
no.
all right.
Hi,
We're hi. We're just waiting for Petar, so the talk starts at
Yeah.
here he is. Yeah.
Hello.
Hey. So,
So I think we're going to wait 5 more minutes because we have a break till 8:30,
sounds good.
and then the participants will be back to watch your talk.
Okay. All right, then let's see you in 5 minutes.
Welcome back, participants. Welcome back, viewers at home. Right now, we are about to have our first business talk of the deep dive days of the TUM.ai Makeathon, and I'm glad to announce that the first talk of the deep dive days is going to be hosted by Dr. Jackie Ma. He has studied mathematics at the Technical University of Berlin. He has done his doctoral thesis with Professor Gita Kimnyok, who now holds the chair of Mathematical Foundations of Artificial Intelligence at LMU. And after his doctoral studies, he went to work at the Fraunhofer Heinrich Hertz Institute, where now he's the head of Applied Machine Learning Group. He will give you a short talk about the applied machine learning projects at the Fraunhofer Institute. And I would like to welcome Dr. Ma. Good evening.
Good evening.
Are you all set and ready to go?
Yes, I'm ready.
Okay, perfect. The stage is yours.
Okay. Yes. Good evening, everyone. Thank you all for having me here tonight. So the title of my talk is Applied Machine Learning, which is a bit misleading because I'm not only talking about work that we do in our Applied Machine Learning group, but I will also show you some of the fundamental research that we do in our department, especially what the other groups are doing. So we have 3 different groups, and I will show you some of the work that we've done there, and but always with a perspective with respect to applications. I want to declare, so whenever I say we, I actually mean others. So we as HHI, but most of the work that I present here is done by other colleagues. So a few words about the Fraunhofer Society in general. So Fraunhofer is the leading organization for applied research in Europe. Since you're all in Munich, or many of you are in Munich, maybe you came across this building there. This is the headquarters of the Fraunhofer Society, and so we have over 72 institutes. They are more or less independent research units, so we are building our own expertise. We are fighting for our own budgets. We are working on different things. So sometimes it makes sense that we collaborate with each other and work on a joint project. But it's rather uncommon that that you see public projects with many different institutes join forces. Sometimes it makes sense, but most of the times we have our own networks, our own expertise, and that's the way how we work. The numbers are a bit outdated, I guess. We have more than 2.3 billion euros budget, but I saw the number for several years now, so I assume that the number is rather on the is rather lower bound. We have around 70% from contracts with industry and from publicly financed competitive research projects, and I will also show you some of them in today's talk. So the Fraunhofer Institute that I'm working for is the Heinrich Hertz Institute in Berlin. We are a global player in research for digital transformation. We have over 600 researchers, an annual budget of over 60 million euros. We have 7 different departments in our institute. We work on artificial intelligence, computer vision, video coding is work where we have contributed significantly. So if you followed the video compression standards, starting from AVC, HEVC, and so on, we have contributed significantly to them. Wireless, photonic components, systems, and sensors. Our, so to say, claim to fame is that every second bit in the internet touches either the video or photonic technology that is invented or made by Fraunhofer HHI. So, like I said, the work that I'm presenting to you today is work that we do at the Department of Artificial Intelligence. At our department, we focus on the research of theoretical and algorithmic foundations of machine learning, on the development of novel methods and models of deep learning, and we are always interested in applying these in new projects. Our institute is led by Dr. Wojciech Zamek, which is this gentleman over here. And we have 3 different research groups. The first one is explainable artificial intelligence, which is led by Wojciech and Sebastian. Then applied machine learning, that is led by Niels and myself. And then we have a third one, efficient deep learning, where Carsten Müller is the head of the group. And like I said, what I'm going to present to you today is some work that the Azure AI group is doing. I will give a very, very short intro into what the efficient deep learning group is doing, and then I show you around, I think, 3 projects of the applied machine learning group. So you all saw in the newspapers everywhere. So some you can fill in the dots yourself, but AI has led to new scientific discoveries. Maybe you saw that someone used neural networks to build an autopilot in the context of autonomous driving, or machine learning is successfully used for analyzing ECG signals. Some companies are building recommender systems using AI. There's hardly any real-time training done by humans anymore. It's mostly clever algorithms that do the job. So we find successful applications of AI essentially everywhere in our daily lives. But besides the success of artificial intelligence, there are still many reasons to remain cautious. It's usually considered a black box model. People don't understand why a certain decision is made, or you can easily fool the system, or you have a domain shift problem, or you have lots of there's still a lot of work to do. So for instance, this is a very basic example, and I'm sure you've all seen it before. You have 2 images that are correctly classified, and then there's the so-called deep fool method, where the images are changed a little bit, and suddenly the algorithm is not classifying them correctly anymore. This you can consider as a toy example, but it could have very, very significant consequences. There are high risk areas where such a method is essentially just disqualified. I mean, you really want things to work in a secure way. You want them to be robust. You want to understand the models before you deploy them. So this leads to the strong need of trustworthy AI methods, and this essentially is important in every part of the AI lifecycle. I'm not just talking about the preparation phase, but also for training, validation, and even more important, during the deployment phase. So the first few slides that I'm showing you are about layer-wise relevance propagation, which has been invented by Sebastian, Wojciech, and other clever people around Klaus Robert Müller. So let's consider the poster child discipline image classification. What's happening? So we have some clever algorithm, some fancy neural network, where I'm showing instances, several images, and it classifies them correctly. So the first one is a rooster, the second one is a castle, and the third one is a car. But what we really want to know is why. This is especially important for certain decisions, for certain areas where maybe even human lives depend on certain decisions. Then you better make sure that someone knows the answer to the question why a certain decision is made, or at least you know someone who knows the answer. So there are different approaches over the years. This is definitely not a complete list of people that have worked on this topic and are still working on this topic. It's just a very short overview of some of the early work. There are perturbation-based methods, function-based methods, structure-based methods, and other methods. And the one that I'm giving a short example for the perturbation-based method. You can think of having a small box that moves around the image, and it distorts certain pixels or deletes them or does some sort of a distortion, and you see whether the classification is still correct or not. You move the little box here around the picture, and at some point, if you really hit the object that is supposed to be the label, it won't work anymore. It's not classified as a castle anymore. But you can imagine that this is a rather slow method, depending on the sizes. It also assumes that the object that you're looking for is actually very, very local. And there are, of course, other image processing problems. You are introducing artifacts and so on. So in general, it's not very recommended to test it in this way. So layer-wise relevance propagation as a method. So let's formalize it a little bit. So suppose I have an input image X. I have my black box model or my algorithm, and it predicts pool table, which is the output f of x. Now, what we really want to have is we want to have a decomposition of our prediction of f of x. I want to decompose it into sum of relevances. And I'm seeking the relevances in my input image because that's how I derived my prediction. So something in this image gave me the reason to say this is a pool table. And I'm looking for a decomposition of my pool table into relevances Ri. Okay, and I'm looking for the Ri in the image. Now we think back to our first analysis course, and there's this nice Taylor approach. I'm definitely sweeping some things here under the rug, but you remember that under some certain assumptions, some regularity assumptions of your function f, and if you choose your root point wisely, you can decompose your function f near the point x, which is our input image, into a sum of first and higher order terms. And if we look at this term here in the middle, we see that we have xi appearing, which are the pixels in our image, times something. And this is a very good candidate for our Ri. Like I said, there's more than the simple formula to it, but it kind of gives you an idea of how things can work. Now the problem is this function f is usually very complicated. I mean, it's easy to say we decompose it like this, but it's not necessarily clear that it even works. So the way how to do it is you decompose the decision function into smaller sub functions that are easier to explain. Hence the name layer-wise relevance propagation. So you're considering these decompositions layer-wise. So what does it mean in practice for our initial task? We have an image, in this case our rooster. Every pixel goes through this network, and we end up somewhere, in this case rooster. And then the job is to move backwards. Starting from the rooster label, we redistribute the relevances backwards. And that's the hard part. Now you have to find clever ways of aggregating these relevances. Here's one of the LRP rules. That's how they are called. How you gather the information and ultimately end up in relevances of your input image. Okay. So this has very nice consequences or applications. You can also ask for what speaks against a certain classification. So if you have relevances that speak for something, in this case we have red corresponds to evidences for a prediction, and the blue color is evidence against a certain prediction. So in this case we have the number 4, and we are asking what speaks not for the number 9. It's this blue part here that is missing, which is also a very good counter evidence, so to say. Another example is face analysis. That's a very nice one as well. So we have 2 pictures where we have to guess the age of these 2 female persons, which in general is not a very feasible task. So the correct class was 25 to 32. which is also where the highest relevance was. So you see, it's still again the same color map. So blue speaks against a certain class or as negative relevance, and red one is positive relevance. So in 25 to 32, everything seems to match. The eyes, the smile, the hair. If we look at the second picture, in the second row, the correct class was 60 plus. And the women, yeah, there's lots of positive relevance, but there's also some negative relevance. In this case, it was the smile. Apparently, 60 plus people smile less, at least in this database. Speaking of databases, what Sebastian and others have tested is then to look at some of the challenges in the past and try to understand whether the different methods that have similar score work in the same way. So in this case, for instance, you have the Fisher vectors and DeepNet and the horse class, and both have around 80% accuracy. And the question was, the guiding research question was whether reasons for classifying the images as a horse were the same. And this was a very interesting experiment because it showed that these two methods looked at completely different things. While one method actually looked a bit at the horse and things that are in the image, the other method put a lot of relevance down here. And the reason why the high relevance was here is because lots of these horse images had a copyright. Which is of course not the reason why you should classify this image as a horse. And like I said, so this method has been applied in lots of different tasks. It's not just image classification, but also in visual question answering. So there are lots of different things where this has been applied, and we have applied this also a lot in the medical domain. Simply because there it is, of course, super important to have such a tool. I mean, anything that you can't explain is probably disqualified from the very beginning. Okay, so let's shift the narrative a little bit, go into what efficient deep learning or some of the very nice results that this group has achieved, which is also more in line with the tracks that you have set in your Makeathon. Nowadays, people are always trying to push the performance really to the limits. We see that people want to acquire more data, people want to develop bigger models. But everything comes with a certain price. So what we also have to think about is what are the consequences of having more data, of having bigger models. This performance is one thing, but there are lots of other things that are fouling. So here's an example for in case of federated learning. So we have a server with an initial model. Someone developed this very, very nice model. And what happens is you send this initial model to several different clients, where every client holds some private data set. And then you have these models are trained locally, trained until some criterion is met. And then they are all sending these information back to the server. And the server is integrating these updates. And after this part is done, it's sent back to the clients. And then the same thing repeats. You do it again and again and again until you're satisfied with the performance. But now, if we keep in mind what I said at the very beginning, this can have immense communication costs. If you're sending these things around all the time, there are many applications where this is really a big issue. So in order to reduce the communication costs, Felix, Simon, and many other people have worked on nice technologies, how to compress these these communication, or how to reduce these communication costs by compression methods. And especially the last one, the Kabak, I want to show you a little bit more of that one, because it has also led to a very fruitful work in the MPEG compression. This is a standard that is currently under development. It's a neural network compression standard in ISO IEC MPEG, where the idea is similar as in lots of these other compression techniques, that you are developing an encoder and decoder model. In this case, you are not applying it, say, frame-wise, if you want to applying it to video compression, but you're actually trying to compress the model. So you have an original neural network that you send through the encoder, and you have lots of different encoding steps, and ultimately you end up with a bit stream that you're that you're setting to the decoder, and you are reconstructing a neural network. And of course, the idea or the main goal is to have an optimal compression rate, meaning that you compress the most, you're trying to compress it, have a very high compression rate while not losing much performance. Okay, and now let's talk about some of the applications that we have. I will probably show you 3.5 projects. The first one is Clips. So as I already mentioned at the very beginning, so we are doing many projects, also publicly funded projects, and this is one of them. I want to show you a little bit of how it works, what we are actually doing, and how these projects are structured. So Clips is a project that develops an AI-based information platform for the localization and simulation of heat islands, with the purpose for innovative urban and transport planning. It's funded by the Federal Ministry of Transport and Digital Infrastructure, which is part of the mFund project. It's a project that has just started, but the idea is the following. So there are lots of external forces, but also lots of local forces that lead to big challenges for cities compared to rural areas. This can be the increase of global warming, the increase of settlement and densification of infrastructure and buildings in cities. And this leads to the following problems. So you have heat absorption and retention in cities that is significantly higher than in rural areas. And of course, the increasing seeding of urban areas is also reducing the plant aspiration, the water evaporation and water penetration, and this can lead to heat islands. And then again, heat islands can lead to serious health hazards, especially for vulnerable population groups. It can also highly damage the infrastructure. And now the idea for Clips is to develop this digital information platform that allows you to detect, forecast, but also simulate heat islands. And the way how this platform will be developed is that you have different types of data sets. You have weather and climate data, certainly, and you combine this with 3D models of buildings, because for the urban planning you have different kinds of models for the houses, how you build them, what kind of roofs do they have, and so on, and you kind of have a simulation for those. And then another data track is coming from satellite images, land cover classes, and so on. And you feed everything into your information and analytics platform, and hopefully what comes out of it are different types of services. Services that allow you to plan a certain city, that can help states and other local authorities, but also the population, to understand the situation and how to deal with it, and how certain plannings can be adapted. Of course, we're not doing this by ourselves. This is how it usually works. You have a group of project partners that share the goals of the project, that have a certain expertise. In this case, we are responsible for the AI-based data analysis. Software is, for instance, responsible for the IoT platform, DLR for providing satellite data. So every partner has a specific role. I mean, they also have their own highly specified expertise. And then we also have application partners, Dresden and Langenfeld, where these things should be deployed and be tested, which we are very happy about. This is data from the DLR. These are the satellite data. Then you can also see that you have different surface temperature, solar radiation, and so on. That's a GeoTIFF file. So these are inputs that we are feeding into the algorithms. And like I said, Dresden and Langenfeld will be our pilot regions, where we deploy this. What I already mentioned is, so for this specific project, there are three services that we aim for. The one thing is the real-time analysis. So you want the localization of the currently occurring heat islands in the urban area with a high spatial resolution. So you really want to see what is happening at the moment. But also you want to have sort of a forecasting. This is then done with the help of machine learning. You want to make a certain prediction over a certain amount of time, and in this particular case, we wanted to make a prediction for the next 48 hours. And then there's also a simulation service, because, like I said, if you're some local authority and you are trying to design how and where to build buildings, such a tool can be very helpful and useful for you. Another project, which is Sauber, it has a similar flavor, but it has different types of data. Is the satellite-based system for real-time display forecasting and simulation of air pollutants for sustainable urban and regional development. It's again a project that is funded by the Federal Ministry of Transport and Digital Infrastructure. This project has already been running for, I think, 2 years, something around that timeline. And the idea is, again, to have a general platform where different data, data that is already analyzed, will be uploaded to. In this case, this is what we call the Sauber platform. So, for instance, HHI is responsible for a certain data type. The DLR is responsible for a certain data type. And then finally, it ends up in a usable web browser. That's the consortium for this particular project. There are some there's some overlap in this project in terms of the research partners, as in the other one. But the purpose is, like I said, the goal is a completely different one, and also the data that we're considering here is different. So here it is that you probably saw it. If you haven't seen it, so essentially in every bigger city in Germany, there are these measurement stations where they measure the air pollution. I don't know how many of them you have in Munich, but I'm sure it's quite a lot. And these are local measurement stations that are usually in a small box. And you combine this type of data where you can really measure the air pollution with other types of data that is for sure relevant for the prediction. Something like the weather data or the traffic data, or the infrastructure data. And then you're trying to make a prediction and determine the pollutant load forecast for the next 2 days. Here are some prediction results from our encoder decoder model, together with some visualizations down there. For the city of Essen, you have higher also lighter colors correspond to higher values, and these are different times, 6 a.m., 12 and 9 p.m. And you can see that there are certain areas at a specific time where the values are much higher. Kind of makes sense. And also in the evening it cools down, and then you have less of it. This is a very interesting upcoming project that is you have to stay tuned for this one. But the idea is that you are combining these hazard-specific data with other types of data that are more that are generated by society. So we're considering two different use cases in this project. The one is epidemics, and the other one are weather extremes. So you have specific data for these types, for these type of hazards. For instance, the infection numbers, or you have the rainfall runoff, and lots of different things that are really corresponding to the hazard. But you also have other types of data. You have mobile data or traffic data in order to have to get an idea of how people are moving, and based on that, you can probably predict how in this case the epidemic is going to develop. And this should be an open platform, a modular platform that is open to further use cases, and also to more different types, so also to other types of data. So other things that are possible that we are not considering in this project could, for instance, be text data coming from news or social media or other things. But this is, like I said, an upcoming project that should start in the next months, that we are very, very excited about to work on. It's also a very large project with more than 10 partners, 10 different partners, and it's this one. Yeah, we like I said, we are very excited to have this one. Now the final thing that I want to tell you about is the ITU WMO UNEP FG AI for NDM. What is it? So let's start with the two letters here, with the F and the G. The focus group is part of the ITU's structure. It supports the efforts of an associated ITU study group. So the ITU is a UN organization that works on develops technical standards, and this complicated name here is part of the study group 2. And study group 2 has the mandate that includes telecommunications for disaster relief, early warning, network resilience, and recovery. The focus group provides a working environment for pre-standardization or standardization activities in a chosen area. And it's also different in the sense that it has a more flexible and dynamic way of working. It can be rapidly established, and also has the freedom to choose the own working methods, the leadership, the financing model, and the desired outputs. And they usually they have a shorter time period than compared to a study group, for instance. Now, here's already some of it decoded, so to say. You have the ITU WMO UNEP focus group on AI for natural disaster management is the actual title of this focus group, and it's working on different, or trying to work on certain key deliverables that can be used to answer the following questions. So through tapping the potential of AI, can we improve our understanding of natural hazards, the ability to detect events in real time, the ability to forecast events, and also the ability to effectively communicate an impending or ongoing disaster, and also what are the best practices and limitations for AI. There are quite a lot of challenges when it comes to deploying machine learning in earth sciences. Lots of the questions they are repeating so these are also questions in other sectors, but it's here for us in this focus group, it's really an adventure trying to get these different communities together. We all believe that AI has great potential for natural disaster management, and it's really up to us to get together and to solve maybe some of the problems that we have. We don't only have. I think we're coming to this in a bit. One more comment. This focus group is the first focus group that combines or that has 3 different UN organizations joining forces. So the AI for natural disaster management converges the ICT expertise of ITU with natural disaster expertise from WMO and UNEP. It creates an atmosphere that is conducive to international multi-stakeholder interdisciplinary collaboration. We not only have ITU and UNEP and the WMO joining forces here, but also the members of the focus group are coming from all over the place, all over the world. We have people from China. We have NASA from the US, IBM. There are lots of different. Also, many universities are joining this initiative. And what are we? When I say explore the best practices, what do I mean by this? So the way how we have structured is we have 3 areas. The data part, where we try to look for the best practices for regarding data collection, monitoring, and handling for training and testing of AI-based algorithms. Then AI-based algorithms for reconstructing, detecting, and forecasting events itself is a very this is more like part of the modeling question. What are the best practices for modeling, and also effective communication? What are the best practices there? So in a bit more detail, some questions regarding data and modeling is: what requirements should data meet when being used to train or test an AI-based algorithm? You kind of want to have a standard for this in order to be comparable. Can AI-based algorithms be used to enhance data quantity and quality? Lots of the data that you find is sometimes it could be noisy. There could be missing values. You can use AI again to complete or to clean the data here. What is the current gold standard method to reconstruct, detect, or forecast events? How can AI-based algorithms bring these methods to the next level? What should be considered when training and evaluating an AI-based algorithm? All these things are super important in order to have the common, not only to be interoperable, but also to be to have the trust in the models that are going to be developed. Communication. Some questions here, for instance, are: once an event has been forecast or triggered, how can AI assist with immediate response? How do we ensure that communication methods are reliable and trusted by the population? Are they accompanied by a clear set of protocols to ensure that individuals know how to respond? So these are examples of the three areas: data, modeling, and also communication. Some of the driving questions. The structure of the focus group is so we have a very diverse management team. The whole focus group is chaired by Dr. Moni Kuglic, who is an innovation manager at Fraunhofer HHI. We have management vice chairs from different countries. We have vice chairs from different organizations, from the Justus Liebig University in Gießen, the World Meteorological Organization, the UN Environment, and many others. And then how the you need a structured way in order to get the information together. So what we have thought would be a good structure is that you have working groups that are more working horizontally. So we have 3 working groups: the working group on data, the working group on modeling, and the working group on communications. The data one is chaired by Alison and Arif from NASA, modeling by Andrea from JRC, from the European Commission, and myself. And the communication one is chaired by Tom Ward from IBM and Ivanka from HHI. And then we have these topic groups. These are the precise use cases, for instance, for flood data monitoring, for landslide, for tsunami detection, and many other use cases, where we kind of get the specific information of how data is treated in this specific use case. What are the best practices regarding modeling? What's considered as the state-of-the-art model in this case? And then the job of the working groups is to have a horizontal presentation of these kind of things. But it's always works. They always work hand in hand with the topic groups. Like I said, there are many more topic groups, more than I can fit on the slide. If you want to have a look, you can check out the link here and go to the focus group of AI for natural disaster management, and then you get a whole list of what the current topic groups are and who is also chairing these topic groups. We are meeting on a regular basis to discuss the progress, and we are also writing up deliverable documents of the respective working groups. And the way how we work is, like I said, so we are organizing workshops regularly. I think we meet around 4 times a year, and then we develop a roadmap. We develop a glossary. We have these non-normative technical reports. These are the deliverable documents of the working groups, and now we are also working on educational material. If you want to get involved, like I said, they both you can go to the ITU website of the focus group. The participation is free. You don't have to pay for it. Join the email lists, show up at the workshops and meetings, and write your own contributions. So what I try to do is try to give you a very broad overview of the things that we do in our department that could be relevant for you. There are many more other projects that I haven't mentioned here. We also have done lots of applications in the medical sector, but I felt these are the projects that could be interesting for you. If you want to stay in touch, if you want to collaborate with us, just let me know, send me an email. And with that, I want to thank you for your attention.
Perfect. Thank you very much for that amazing talk. And we have all enjoyed the different projects that you have showed us tonight. And now it's time for the Q&A session. We have received 2 questions already in the channel. So participants, if you have any questions to Dr. Ahmad, then feel free to write them in channel number 2, workshops and talks. And yes, we can start with one question. How does layer-wise relevance propagation compare with attention? And additional, can attention also be used to interpret the model?
Yeah, so there are lots of, like I said, there are many different interpretation tools. There's also an upcoming, or I'm not sure if it's already even published, work on the evaluation of different types of interpretation tools. I probably have to look up the link, and then I can send the one to you.
Perfect. Then, while we wait, some participant is typing currently. I have one question. You showed us the decomposition process, and does this decomposition, i.e., the negative relevance, only work with dense neural networks, or can we also apply it on much more complicated, for example, convolutional neural networks or something like that?
Yeah, it has been applied, or it has been developed for many different types of models. We have also applied them for LSTMs and other things. But you always need the model in order to do these kind of things. So it's not that you have this general method and then it can be applied to any model. So you always have to do some tweaking.
Perfect. And you also showed us some compression methods. And do you think that the compression of neural network plays a vital role in the Internet of Things, as such devices are not as capable of, are not as computationally powerful as a standard computer? Do you think that this compression can also be transferred to the Internet of Things?
I hope so. It's I mean, I know that people are trying to do this. It's not so easy, but I mean, I think you can get something out of it. Yes.
Perfect. And talking about neural network compression, we just got in a question. Where can I learn more about neural network compression? Can you please name the research articles I can consult for this?
Yeah, I can put them into the chat.
Perfect. I think we can wait a second or two if there's any more additional questions. Maybe another question is, you showed us negative relevance on pictures. Do you think that negative relevance can be applied on other types of data sets, for example, audio data or something else?
Yeah, this is a very, very good question. So what we are doing, or what the XAI group is doing, is going beyond these visual interpretations. The nice thing about visual interpretations is that you, as a human, can very easily understand what it actually means. But if you have different types of data, not just only audio data, but if you think about sales data or data that is really that is not essentially not visual. It's very hard to understand whether the reasoning is correct or not. I mean, it shows you some relevance. You get sort of a heat map, but it's not a visual one. So it's very difficult to you need other types of valuation tools. Then you can think about clustering them and kind of seeing bigger structures. But yes, so you can essentially apply it to any kind of data. The question is how you can interpret these heat maps.
Perfect. I'll just check if there's an additional question. I don't see any. I think we've covered it all. Would you like to add something to your talk or any comments?
No, I just probably I can use the chance to congratulate you all on doing this very, very nice student initiative, and that's very, very important. And I wish you all continuing fruitful days of interesting talks.
Perfect. Sounds amazing. Well, dear viewers and participants, that was Dr. Jackie Ma. He gave the first business talk about applied machine learning. Tomorrow we'll have the second deep dive day with another workshop and another business talk. And once again, Dr. Jackie Ma, it was a pleasure having you.
Thank you all.
Thank you very much.
Bye. Bye.
Bye. So, dear viewers, I would also like to mention that we have ended our first official deep dive day, and we'll see each other again tomorrow at 7 p.m. That is Central European Summertime. And till then, I wish you a pleasant night.